Okay, suppose we play some game. Play game. Let's just do 4 times in succession. And suppose probability, let's say Wi is equal to a third for I equals 1, 2, 4. That's the probability we win equals we win game I. Okay, and we will assume the trials are independent. We're basically must assume that because we're not given any more information on the probability. So we would have, if we're told it's a third every time, then they must be independent. Okay, so it's kind of a tacit assumption. I don't think it needs to be stated. Okay, play game 4 times. Probability we win any game is a third. Let's call it PEI again, where EI is we win I times, and now I is 0 to 4. Okay, so we're going to build the same kind of histogram this time, only we have 4 trials in our big experiment, and our events look like W1, W2, W3 complement, W4, something like that. So, all right, so E0 that we don't win at all, this is just the single experiment, this is just the single outcome. The intersection of these, right? So probability of E0 is just equal to probability W1C, probability and this is by independence. Right, I can just multiply them. Now, since they're each, the probability I lose every time, this is 2/3 each time, so I get 2/3 to the 4th power, so I have 16 over 81. So roughly, there's only a 20% chance that I lose every time. Okay, now, what about PE1? Well, PE1, all the ways, right? All the ways I can win one. So this would be W1 or W1C, W2, W3C, W4, or right? Just to show you the gory detail. Now, ME, so P, this should be equals. I was so excited about the adding. So this from the ME is equal to P, W1, W2C, W3C, W4C, plus, now I want to write the other one. You could feel free to fast forward this. This should be a C. Okay, plus. I went on the 3rd time, plus. Getting lulled into, okay, there we go. So it's these, and this is from ME. And now, from the independence, what do we have? Each of these is equal to the product, right? Each of these is equal to the product. So the first one is 1/3, 2/3 cubed, plus the next one would be same thing, right? Same thing, same thing, same thing, same thing. I have 1/3 times 2/3 cubed, plus, I will only do this one. So we have 4, 1/3, 2/3 cubed. I get an 81 on the bottom. On the top, I have an 8 and a 4. So I have 32 over 81. Okay. Now I expect you to take the jump. So PE2, how many ways could there be 2 wins? Well, there was actually 4 choose 1 ways for there to be 1. So here there's 4 choose 2 ways for there to be 2. And now I have 1/3 gets squared and 2/3 also gets squared because there's 2 of each. And so I have 4 times 6, 24 over 81. Well, we have to keep going. These will not be the same because the probabilities are not symmetric. So let's keep going. PE3. Here, I think I can do it here like this. PE3. I have 4 times 2, so that's 8. And finally, PE4, only one way, to the 4th power. Got to win them all. That's 1 over 81. So if I draw these out, let's see, 0 gave me 16. So 0 was 16, say. Okay, this is, sorry. Let me draw it down here. Getting too excited. Okay, so 0 was 16, right? Yeah. And then 1 was 32. So 1 was the biggest. 1 is double that. And then 2 was 24, actually the midpoint between these. And then 3 was 8, which is actually half of this. And then finally 4 was 1, so 1/8. Okay, so these are the probabilities. This is 32. 16. Okay, this is a probability of EI. Okay. All right. I think we'll stop. We got a different problem. And I'll see you on the other side.